Okay, so we're starting a new chapter, chapter 11, and we're going to look at what are called rigid motions. Sometimes you'll hear these called transformations. Okay, so we're looking at moving an object from a starting position to an ending position without changing its size or shape. So, since the size and shape are not altered, the distance between the points remains the same. Okay, so this is another way of saying the shapes are going to be congruent. Okay, so we're not going to change our shape, we're just going to move it around in some way. So there are four types. The one we're going to look at first is a translation. And a translation is basically a slide. We're going to take our object, we might move it left, right, up, or down. So let's go ahead and fill out that number one right here. So a translation is a rigid motion that moves an object up or down and possibly left or right a specified number of places. So we're going to be doing these on a grid or a graph. The second one is a reflection. And you can think of a reflection as a flip. So for a reflection, we're going to move the object into a new position that is a mirror image of the original. The mirror is called the axis of reflection. So this mirror for us will be a line. So we're basically going to have a line and we're going to reflect or fold on that line. All right, so to find a point's mirror image when it's reflected over the axis of reflection, we're going to draw a line that goes through the point and is perpendicular to our line. So remember, perpendicular means it forms 90-degree angles. Okay, the point's mirror image will fall on the line drawn and be equidistant from L. Okay, so this will make more sense when we actually do some reflections. Next we have a rotation. So a rotation is a turn. Okay, so a rotation is a rigid motion that pivots or swings an object around a fixed point O. Our book calls this the rotocenter. I've also heard it called the center of rotation. Okay, so when we're doing a rotation, we have our fixed point, which is going to be our center of rotation. And then we need an angle and a direction. Right, so maybe we want to rotate 90 degrees, and the direction will be either clockwise, right, so basically going this way, or counterclockwise, which would be rotating back this way. So the way the clock goes is clockwise, opposite of the way the clock goes is counterclockwise. All right, so we're going to concentrate when we do rotations. We're going to do 90, 180, and 270. So these are nice because a 90-degree turn is basically turning something on its side. So this would be one 90-degree turn, two 90-degree turns, and three 90-degree turns. So when we get to this, we'll follow these directions. Okay, we'll rotate the paper in the direction and degrees indicated. Read the coordinates as though looking at a regular coordinate grid. We'll write them down as A prime, B prime, etc. then we'll turn the paper back to its original position and plot the points you wrote down. All right, so when we get to this, we'll come back and look at these directions, and then we'll kind of show you how that's going to work.